All right, Year 10, I've decided quickly to put a video together for you to help you with your Logger Pro analysis. This is something you can watch then in your own time. We do need to get this analysis done, though, as quick as we can, but it will be helpful for your future physics stuff. First thing we need to do, I've got the software open here. This is version 13. I haven't upgraded to version 15. I'm not quite sure what the differences are. I think it'd only be subtle, so we should find this will be suitable. First thing we need to do is go up to Insert and insert the movie file that we want to analyze. So insert movie. Find the file that you want. So you should have it saved somewhere sensible. I'm actually going to do the 375mm launches that Kyle and the girls put together, which actually they've done a really great job. They were very good launches, close to vertical. They used 35 psi, which didn't overload the pressure on the launches and appeared in the end to possibly be a good move forward for future investigations, and got some great launches still, but that's beside the point right now. But good launches. Double click or highlight and click on open. It does take a few moments for it to open up the movie file. It doesn't happen immediately, so you just need to give it a moment. Just be patient. Now move your footage up a little bit and then drag it out. Make it as big as you can. Now I don't want to analyze a lot of unnecessary stuff when the rocket is on the launcher and hadn't taken off. Better be safe than sorry, so I'm glad you guys started the footage early. But what we'll do is down the bottom with the slide bar, slide forward until just after the rocket takes off. So the rocket's gone off the launcher now. Use these little two tabs here, or little arrows, double arrow right, double arrow left. We'll move backwards. One at a time. Here comes the rocket back down to ground. Rocket's back on the launcher, clearly on the launcher now. One slide later it takes off. One slide back, it's on the launcher. I'm going to go one step further back just to get that takeoff. Now it's time to bring up the analysis tools. So 3 red dots and a black arrow. Bring them up. First job is to set the scale, which is this yellow, I guess it looks like a ruler, but if you hold your cursor over it, it does say set scale. Highlight on there. Now, do it just to the side of your bottle. I've lined up the crosshair, the left arm of the crosshair with the top of the rocket. Hold the mouse button down, drag down to the bottom. Try and keep your line vertical. It's not quite vertical. Maybe I'll cancel that. Try again. Be a bit fussy here. This is a critical part though. Top to bottom. Still not quite vertical, but I'll accept that. 0.45 meters, 45 centimeters, and done. Go across, second from the top, set points or add point, highlight shades black to say you've selected that tool, go across and center of your rocket. First click, it shouldn't go anywhere. Second, and then it takes off from the launch. You have to be very careful. I can see it there. See it there. It's still accelerating. Now it looks like it's ceased acceleration, definitely with that drop in displacement. Acceleration phase is over. A couple of dots just passed, and then I'll call it quits. What I'll do next is add the X and Y axes. So third from the top, set origin. Highlight there. Go down to my first dot. Center of my first dot, and put that's close enough. Put the XY axis on there. So it veered a little bit off to the left from vertical, but yeah, still a very good flight, really. Okay, moving back now, grab the pointer at the top just so you don't accidentally put any data points on the screen that you don't want there. Move across, click on the graph in the background. The blue dots here represent the Y displacement. Okay, the red dots represent the X displacement. Just veered a little bit in a negative direction. That's to the left. And we don't want those though. If we go across to here, we worked out together in class, we want the y velocity. So by clicking on the labels on the y-axis, we can choose y velocity. Nice pattern here of acceleration up to where it started to slow down under the force of gravity and air resistance, and also that no more water being thrust out the bottom. So Newton's third law, equal and opposite reactions, was over. There was no more thrust. So that's good footage there. We want to analyse that first part of the flight with a linear fit. You can see a little black square brackets here and over here. Okay, we want to drag those across and approximately do a line of best fit. Data point above, data point below, data point on, data point on, data point below. That's pretty good. And we get 340.4 meters per second squared, or meters per second, or meters per second squared, and that's the acceleration during the launch. Click to the left just to get rid of that shaded area. File and save as. And this is not the first time I've done this tonight, trying to get this right. So I'm going to just save over my launch one analysis. And then what I can also do now, and you guys will be doing this with your assignment, is right click and copy on the graph. And I can open up a Word document. I can make sure I give my graph a decent title. Right, and I can paste the graph into the Word document. That's what you guys will be doing for your report. You can also take the data, which is here, and you can also copy the data table into your assignment as well. But I'm happy more at this stage just with the graphs. It's fine. If you've done the analysis properly, that's okay. What you need to also make sure you do is, as I said, save it. So if you need to come back to it and adjust it or whatever, you can do that. You can click back to the footage. You can click back to the graph. You can click back to the data table. When you're ready to do the next one, it's File and New. Save any changes if you made some changes. Insert movie. Insert the second one. Once again, be patient. It takes a little while. I'll see how quickly I can get this one done. I don't expect you to do it quickly. I'd rather you take your time and get it right, but I can try and show you that it doesn't have to be super time consuming. Drag it up, make the footage bigger, skip forward to where the rocket takes off. Must be close. Okay, it's taken off. There it is up in the air there. Use the left arrows to bring it back down to ground. It's back on the launcher. One step further back. Bring up my tools. Set scale. Be careful here. Getting fussy now. Top of the rocket, bottom of the rocket. Move it to the left. Try again. Happy with that? 0.45, 45 centimeters. And point into my rocket. Won't move for the first one. Second one, just moved. You got to keep a close eye on it. Oh, that's a bit hard to see. Yeah. No, this is a good launch. Still accelerating. Now it's starting to slow down. You can see the displacement. Less. One more and done. Add my origin on the first data point. And back to cursor. Back to the graph. Very close to a vertical flight. Nice Y displacement there, but I don't want to look at either of those. That's not what we're interested in. Y velocity. Great linear pattern there on the acceleration. Very nice. Analyze. Linear fit. Bring my cursor back. Okay, this one's a bit higher than the last one. 382. It's a big discrepancy there. I'll leave it at that, 382. So I'll average that out with my other one of the 340, whatever it was. File, save as. Launch number 2, replace, and I'm done. I'm ready to copy that graph. And I had done this before, but paste it into the assignment. Actually give it a proper title. Add in 35 psi. Why not? The more detail, the better in the title. And you're done. So that's it. It's relatively straightforward. I've done 2 out of the minimum 6 you need to do. Didn't take that long, and that's exactly how you do it. Some really good results here. Average, that'll be about an average of 360, which is, again, that's pretty consistent considering how we've done here. I did a couple more earlier that actually were much, much closer even. So maybe my scale on this one was a little short. I'm not sure. But anyway, I'm still happy with those results. Nice linear pattern during the acceleration phase of the launch. And that's what we're after, guys. In class, I'll try and show you a little bit more about how to possibly put this stuff into the Excel spreadsheet, how to use Newton's second law to work out the launch force. But of course, F equals ma, so we know the mass of the bottle with the water in it, and we know the acceleration now, so that's a relatively straightforward calculation to work out the launch force as well. But we'll do that in class. Hope that helps. We need to get this done as soon as possible to help keep your drafts moving forward so you can start on the write-up and the secondary analysis of the data we've gathered here with our launch analysis. Okay, well, I'll see you in class very soon. Okay, hope it helps. Bye-bye.